Hey there, and welcome to The Explainer. Today, we're diving into something really cool, the absolute core building block of, well, all software. I mean, whether it's the banking system you use every day, those addictive apps on your phone, or even the complex software keeping your car on the road, it all relies heavily on the foundations of functional programming.
Now, have you ever actually stopped to wonder how these massive software programs don't just, completely collapse under their own weight? Seriously, with millions upon millions of lines of code, trying to keep track of every single moving piece without it turning into a totally unmanageable mess. Well, it honestly seems nearly impossible, right?
While the foundational mental model that solves all that chaos is something called the function. At its core, a function is just a self-contained block of code designed to perform a specific reusable task. And that phrase right there, self-contained, that is absolutely the secret weapon here. It essentially puts this protective boundary around an action so its state doesn't bleed into the rest of the software. And what does that mean for us? Way fewer bugs and highly reliable systems.
To make this abstract idea a bit more tangible, I want you to think of a function kind of like a recipe within your main program. Just like a busy kitchen uses specific recipes to avoid, reinventing a meal from scratch every single time someone orders it, a complex codebase uses these little mini programs to reliably execute tasks without ever needing to rewrite the underlying logic. The mechanics of it are completely linear. First, you give it the inputs, the raw data. Second, the function processes that data using its specific internal logic. And third, you get your output. It basically takes a really complex operation and turns it into a perfectly predictable, reliable exchange. Data goes in, and exactly what you need comes out on the other side. Actually, quick side note on the terminology here, just so we're all on the same page. Depending on the programming language you're looking at, you might hear a few different terms thrown around. Like in object-oriented languages, take Java, for example. These are really commonly referred to as methods. But don't let that confuse you. It's the exact same fundamental concept, just wearing a different name tag depending on its environment. Okay, so why is this self-contained organization so absolutely vital? Let's imagine for a second you're writing a billing system, and you are forced to manually write out the tax calculation logic over and over and over again. Every single purchase, every single invoice, you are literally sitting there typing out the exact same math. Sounds like a nightmare, right? Imagine needing to calculate that tax 50 different times across your software system. 50. That is 50 different places where you have to type the math flawlessly, and 50 separate chances to make a tiny typo that completely ruins a customer's billing statement. That kind of repetitive inefficiency is exactly what makes complex systems so unstable. And this right here is where the function proves its architectural elegance. Instead of all that mind-numbing repetition, you write the logic once, you package it up nicely, and you give it a clear, simple name, like calculate tax. Then, whenever the program needs it, it simply calls that function and instantly gets the answer. Boom, done. This approach gives us three massive architectural pillars. Number one is reusability. You write it once, and you can use it infinitely. Number two is organization. It lets us break down these massive, intimidating programs into easily manageable chunks. And number three, which is absolutely crucial, is easy maintenance. If the tax laws suddenly change, you don't panic. You just update the logic in one single place inside that function, and the entire system is instantly accurate. It's a total game changer.
It really is such a powerful mental model. So I want to leave you with this little thought to ponder. How could this concept of write once, use infinitely apply to problem solving outside of just code? I mean, once you start viewing your own workflows and daily routines as reusable functions, you'll realize just how much daily chaos you can actually conquer. Thanks so much for joining me for this explainer.